let's say there are two bodies on the axis. This we say is x-axis and this we say y-axis. From here there are two bodies A and B at origin. Both of them they start moving in this direction, and after some time B is over here and A is over here. Certainly the speed or velocity of B is higher as compared to velocity or speed of A. This is moving in this direction, this is moving in this direction. So it means at time t, from here to here we can call it as displacement of B, and from here to here we can say this is displacement of A. So anytime the displacement of B with respect to A is this much, that is displacement of B as seen by or with respect to A is what? SB, displacement of B minus displacement of A. If we differentiate it with respect to time or we divide it by time, so this comes out to be velocity of B as seen by A is equal to velocity of B minus velocity of A. If we differentiate once again with respect to time or divide by time, we say this is acceleration of B with respect to A is equal to acceleration of B minus acceleration of A. So this is the basic thing we shall be using, be it we have to find the relative displacement or relative velocity or relative acceleration. Now let's understand it by a few examples. Over here what we can do is we can take the velocities obviously in one direction as positive, then in the other direction as negative. If you are taking the velocity in the upward direction as positive, so in the downward direction they have to be taken as negative. Be it velocities, be it displacement or be it acceleration, these are vector quantities. So accordingly we can opt for any sign convention. Let's say now there are two bodies and this is going this way, this person is going this way with 20 meter per second. Let's say we call it as B, and this is A which is going this way with 5 meter per second. We have been asked what is velocity of B as seen by A. So it is VB minus VA only, we have just done it. So what is VB? It is going, this person is going in this direction, so this direction is taken as positive, so it is going to be plus 20 minus VA. This person is also going in this direction, so this velocity is also positive. So this VB minus VA, VB minus VA, this minus this, what is this? This is plus 5. So this comes out to be plus 15 meter per second. So this is velocity of B as seen by A is 15 meter per second. So it means to this person, it will feel like that this person is moving in this direction with respect to him with a velocity of 15 meter per second. If his velocity is 20 meter per second, then certainly this person is stationary with respect to him, because in every second he is traveling 20 meter and he is also traveling 20 meter in every second. As a result, the distance between the two, it remains same. Whatsoever is the initial distance, the same distance will be maintained. So it means that this is stationary with respect to him, or he is also stationary with respect to this person. So the relative velocity is going to be equal to 0. Now let's say this person B is going in this direction with 20 meter per second and A is going in this direction with 5 meter per second. This way we are taking the velocities as positive, this way we are taking it as negative. We are asked what is velocity of B as seen by A is obviously going to VB minus VA. So this is VB is in this direction is positive, so it is plus 20 minus this velocity is in this direction is negative, so it is minus 5. So 20 minus minus 5 is 25 meter per second. So this person will see this person going in this direction, that is comes out to positive. That is, this person will feel that this person is going in this direction away from him with the velocity of 25 meter per second. If you have to find what is velocity of A as seen by B, we have to find it. Then certainly if this person feels that this is moving in this direction 25 meter per second, so obviously this person will see this person moving in this direction 25 meter per second. Let's do it. So VAB is equal to VA minus VB. What is VA? VA is minus 5 minus, so this is VB is what? Plus 20. So minus 5 minus 20 is minus 25 meter per second. So this is velocity of what? This is velocity of A as seen by B. B will see this person moving in this direction, negative direction, with the value of 25 meter per second. As we have found the relative velocity along x-axis, same way we can also find the relative velocity along y-axis also. Now let's say this is x and y axis. This is x axis, this is y axis, x dash, y dash, and over here a person is moving in this direction. Let's say body A is moving in direction at an angle of 45 degree with a velocity of 10 root 2 meter per second, and body B is moving in this quadrant at an angle of 45 degree, and this person is also moving with 10 root 2 meter per second. We have to find what is velocity of B as seen by A. That is, we have to find what is velocity of B as seen by A. So let's find the velocity of B as seen by A along the x-axis as well as along the y-axis. So for that, what we do is we break this velocity into its components along the x-axis and along y-axis. So this is 10 root 2. So what we do is this 10 root 2 meter per second can be broken into this component and this component. This angle is 45 degree. Through the basic knowledge of vectors, we know this is going to be cos component, that is 10 root 2 cos 45 degree, and this is going to be 10 root 2 sin 45 degree. Cos 45 as well as sin 45, when we say cos 45 degree, we know is equal to sin 45 degree is equal to 1 by root 2. So this value, it comes out to be 10 root 2 into cos 45 is 1 by root 2. So this comes out to 10 meter per second. Similarly, this will also come out to be 10 meter per second. So it means this velocity can be broken into two components. One is the velocity of A is going to be 10 meter per second along the x-axis, and the velocity of A along y-axis is also going to be 10 meter per second along the y-axis. Similarly, this velocity can be broken into two parts, one component over here, the one component over here. So the velocity of B can also be broken. One is this way, 10 meter per second, and this is also 10 meter per second. This is B. Now our job is much easier. We have velocity of 10 meter per second this way, we have velocity of 10 meter per second of this body in this direction. So what is the relative velocity of B as seen by A or as seen by B? It is 0, because both of them, they are moving along the y-axis with the same velocity. So it is happening something like this. This is one body, this is other body. They are moving like this. So whatsoever is the y coordinate for this at any time, this is also y coordinate for this time. So no one has advantage. Both of them, they are having a same velocity in this direction. It means the relative velocity on the y-axis is going to be equal to 0. Or if we wish to apply it, that is VBA along y-axis. So we say VB, velocity of B along y-axis minus velocity of A along y-axis. So it is going to be 10 in the upward direction plus 10 minus plus 10 is equal to 0. So the relative velocity along the y-axis, we see it as equal to 0. So the only velocity of B as seen by A along x-axis is going to be velocity of B along x-axis minus velocity of A along x-axis. And what is that? Velocity of B as seen by A, VB in this direction. How much? It is minus 10 meter per second minus velocity of A. Velocity of A is 10 meter per second. So this comes out to be minus 20 meter per second. This is along the x-axis. So this person will feel this person is moving in this direction with the velocity of 20 meter per second. Negative sign says that is to him, it will feel like that is this person is moving in this direction. And what is the velocity of A as seen by B? It will be 20 meter per second in this direction. In this case, the components of velocities of both these bodies, they had been equal, they had been same along the y-axis. What if that is different? In that case, we are going to have a relative velocity along the x-axis also, and we are going to have a relative velocity along y-axis also, and we can find a resultant of the relative velocity along x-axis as well as along y-axis. Let's do it. Now let's say this body has a velocity of, once again we have x-axis over here, y-axis over here. A has a velocity of 10 root 2 meter per second in this direction at angle of 45 degree. This is, we say this is body A and this is body B. It is moving with 20 root 2 meter per second at angle of 45 degree. Only for convenience, we have taken these values and taken as angle as 45 degree only, so that calculation they become much easier. So first thing is, let's make the components of these two velocities of body A and body B. So these components, they are going to be, the velocity component of this along x-axis is going to be 10 meter per second, and this is also going to be 10 meter per second. for A, obviously this is going to be 10 root 2 cos 45. Cos 45 is 1 by root 2, so this will come out to be 10 meter per second, and this way also it will come out to be 10 meter per second, as we have done just now. So for this, it is going to be 20 root 2 cos 45, cos 45 1 by root 2, so this is going to be 20 meter per second, and this component is going to be 20 meter per second. Obviously this is going to be much longer arrow as compared to this, because this is 10 meter per second. This has to be longer than this. So this is for body B. Now we are interested in finding what is velocity of B as seen by A. So what we do is, first we find the relative velocity of these two bodies along the x-axis, and we find the relative velocity on y-axis also, and then we find the resultant velocity which is going to be seen by A. So velocity of B as seen by A along x-axis is velocity of B along x-axis minus velocity of A along x-axis. This way, let's say we take the vectors as positive, and this way we take it as negative. This way we take it as positive, and this way we take it as negative. Let's stick to this sign convention. So VBX, velocity of B along x-axis, this is A, this is B. So velocity of B is minus 20 meter per second minus VA, it is 10 meter per second. So this comes out to be minus 30 meter per second. Velocity of B as seen by A along x-axis, it comes out to minus 30 meter per second. So it means to this person, he'll feel that this person is moving along the x-axis in this direction, negative means in this direction, with a velocity of 30 meter per second. Now let's find velocity of B as seen by A along the y-axis. Velocity of B as seen by A along y-axis is velocity of B along y-axis minus velocity of A along y-axis is VB. Velocity of B along y-axis is 20 meter per second in the upward direction. Upward direction is positive only. So this is 20 plus 20 minus velocity of A along y-axis. It is 10 meter per second in the upward direction. Upward direction is positive only. So this is going to be plus 10. So this comes out to be 10 meter per second. So this is velocity of B as seen by A along y-axis. So now what is the net velocity A will see of B? If we talk about the relative velocity, so this person A will see that this person B has a velocity of 30 meter per second in this direction, as well as a velocity of 10 meter per second in this direction. As a result, the net resultant velocity of this person as seen by body A is going to be this. That is, this is going to be V net velocity. So V net velocity, so V net is the net relative velocity of body B as seen by A, is going to be under root of this square plus this square. We are using Pythagoras theorem only. And if I have to find the angle also, at what angle he will find that this body is moving in this direction is theta. So this is 30 meter per second, this is 10 meter per second. So if we take this right angle triangle, so over here this is 30 meter per second and this is 10 meter per second. So this is also 10 meter per second. Both of them, they are same physical quantities, velocity, velocity. And if you have to find this angle, so tan theta is going to be perpendicular base, that is 10 by 30. So theta is equal to tan inverse 1 by 3 is the angle at which he will see this body moving in this direction with the magnitude of this under root of 10 square plus 30 square meter per second and at angle of tan inverse 1 by 3. We can also denote this velocity in terms of the standard vector notation comprising of I cap, j cap and k cap also. And if we intend to get the answer directly without finding first the relative velocity along the x-axis and the net relative velocity along the y-axis and then finding the resultant, so you can directly apply VBA is equal to VB minus VA. That is, VBA is equal to VB minus VA, and these velocities you can take in vector notation. So now over here velocity of B, if we see, is going to be this way, it is 20 meter per second, so it is going to be minus 20 I cap, and this way plus 20 j cap meter per second obviously, and velocity of A is going to be 10 I cap plus 10 j cap meter per second. then we can directly put the values of these velocity of B and velocity of A in this. So this velocity of B as seen by A comes out to be minus 20I plus 20J minus velocity of A, that is 10I plus 10J cap. So this comes out to be minus 20I plus 20J cap minus 20I minus 10J cap. So this is velocity of B as seen by A again. So velocity of B as seen by A is equal to minus 20I minus 10I. So this is going to be minus 30I. Minus 30I, once again it means this is a relative velocity along x-axis, that is 30 meter per second in this direction only. And in terms of J, it comes out 20J minus 10J. So this is plus 10J only. That is the relative velocity along y-axis. This body will see of this is 10 meter per second in this direction, means the same thing. And what is the magnitude this comes out to be? If you have to find the magnitude of this, that is velocity of B as seen by A, and its magnitude is going to be this square plus this square under root, that is minus 30 square plus 10 square. So this is meter per second, we'll get the answer in meter per second. This is exactly the same what we have got earlier also. And the angle, so this is minus 30. So 30 meter per second, it means in this direction. And 10J, the relative velocity of this is in this direction. This is 10J, 10 meter per second. So net velocity is going to be like this, and theta is going to be, once again, tan theta is going to be 10 by 30. So theta is going to be tan inverse 1 by 3. We get the same thing. So this is how we can find the relative velocity directly. First, taking the velocities of A and B in vector notation, and then we directly subtract the velocity of A from the velocity of B to find VBA, that is velocity of B minus velocity of A.